So up until this point, we have been dealing with solving equations, right? Look, now I'm not sharing with you guys at all anymore. What's up with that? Hold on, it's coming, I promise. I know you're all anxious to learn all of this. All right, we're good now. We're good. So, up until this point, we have been dealing with solving equations, right? And that's all we're really doing today as well. But we're solving what we call absolute value equations. And you guys have dealt with absolute values before, um, but not necessarily with a variable in it. So, we're going to deal with how to solve absolute value equations. There's a little bug flying by me. I'm not losing my mind. Like, if you see me, like, now, when we're talking about absolute value equations, there's a couple steps involved with solving them. The first is to isolate the absolute value. Just like when we'd isolate a variable, we want the isolate the absolute value. So just like when we were isolating a variable, we want the absolute value and its contents, what it's holding inside, to be the only thing on one side of the equal sign, right? That's what it means by isolating the absolute value. Number two, I wanted it to make a pretty circle. It didn't. Create two cases. One set equal to the positive. I'll just say plus. One set equal to negative. And I will show you what all of this means. Number three, solve both equations. And four, the least important part, or the most important, depending on who you ask. Check. That's an E. Check for extraneous solutions. That is solutions that don't fit, right? It means plug them back in, your solutions that you get, plug them back in and check and see if they work. Now, some of you may remember when we dealt with absolute value problems in the past that if I had something like the absolute value of -3, it would just equal 3. In the same case that the absolute value of 3 also would equal 3. And that's all about the fact that we're dealing with distance from 0 on a number line, right? If I had a number line and I had 0 here, right? And I had something, say, 3 away from 0 in this direction or 3 away from 0 in this direction, it's still just a distance of 3, right? No matter which direction we go, it's still just a distance of 3. Positive and negative just means negative means it goes in the negative direction. Positive means it's going in that positive direction, right? But it's still just a distance from 3 from 0, right? And no matter which way we go, it's still only 3 places away from 0, whether it's positive or negative. Does that make some sense? The last piece of information I have to give you before I get into example problems is if I have something like the absolute value of x, it cannot equal something negative, right? Now, if I have -3 plus the absolute value of x or something like that, it can equal something negative. But once I get this all by itself, so it's the only thing on this side of the equal sign, it can't have a negative solution. And if you think about that, it makes sense, right? Because if I have any value of x in here and I pull it out of the absolute value signs, it's going to be positive, right? So I think those are all of my little points I needed to make before we start playing with this. So let's look at examples. First example, we'll call number 1 because it fits. If I have the absolute value of x minus 9 set equal to 5, right? If we look back at the steps that we just wrote, the first one it tells us to do is to isolate the absolute value. That means the only thing that can be on one side of the equal sign is the absolute values and what's inside it. And it's already isolated, right? The only thing that we have on this side of the equal sign is contained in that absolute value. So step 1 is already done for us, which means that we're going to move on to step 2. And step 2 tells us to create 2 equations, right? 2 cases. One set equal to the positive and one set equal to the negative. And that means we're going to take everything inside this absolute value, x minus 9, and we're going to set it to positive 5. And then we're going to take it and we're going to go x minus 9 equals negative 5. And we're going to solve both of those problems, right? We're going to have potentially 2 solutions to every problem. So here we just have to solve this for x, right? So we're going to go ahead and we're going to add 9 to both sides. And we're going to get x equals 14. Here we're going to do the same thing. We're going to add 9 to both sides. And we're going to get x equals 4. These are my 2 solutions, 4 and 14. The last piece that it asks us to do is to check for extraneous solutions. All that means is we're going to take these and plug them in here and see if they work. Do you have to show that on every problem? No. Most of the time you can mentally do it, right? But I'm going to show it to you for the sake of, being a teacher and all. So if I plug in 14, I would have 14 minus 9 equals 5. And the absolute value of 14 minus 9 is the absolute value of 5 equals 5. And the absolute value of 5 is just 5 equals 5. So this is true. We're going to do the same thing with 4. We're going to go the absolute value of 4 minus 9 equals 5. Well, that's the absolute value of negative 5. And the absolute value of negative 5 is just 5. So it is also true. So we've proven that both of these actually work. What would happen if one of them didn't work? And occasionally it will happen where one of them doesn't work. Then you only have one solution, right? And that will happen. I know in the Delta math, they've thrown in 1 or 2 of those where there is an extraneous solution. And if you put in both solutions, it's going to be wrong, right? Because one of them isn't a correct solution. So on this one, we didn't have to do anything. Everything was already isolated. So we're going to look at one where we have to do a little work on it before we can get to the solving. Let's look at, we'll call it number 2 because it's the second one. I like to work like that. What if I have the absolute value of y minus 1 plus 17 equals 23? So the first thing we have to do is isolate that absolute value. And there is something being done to the outside of that absolute value, what is being done? And it's got that plus 17 on it. So we're going to do the opposite of plus 17. And we're going to subtract 17, and we're going to do it from both sides of the equations to maintain the equality. And because it is the law of algebra, right? You can't do something to one side of an equal sign and not do it to the other side of an equal sign, or it's no longer equal. So if I do this, I'm left with the absolute value of y minus 1, and these cancel out, equals 23 minus 17, which is just 6. So now we're isolated. Oh, like 17 plus. Rated R. This problem is rated R. So now that it's isolated, we're going to create our two cases. One case is going to be y minus 1 equals 6. And the other one will be y minus 1 equals negative 6. We're going to solve those two problems. How are we going to do that? We're going to add 1 to both sides. Heck, I could go ahead and do that here too, right? Add 1 to both sides. Here I'm going to be left with y equals 7. I always draw a line on my 7s because, I don't know why. Y equals negative 5. Now we're going to plug those in to the original equation and see if they work. Now I can do this mentally, but just for the sake of fun, we're going to go, okay, well, 7 minus 1 plus 17, does it equal 23? 7 minus 1 is the absolute value of 6 plus 17, which is just 6 plus 17, which does equal 23. If I plug in the other one, I've got negative 5 minus 1 plus 17 equals 23. Well, negative 5 minus 1 is the absolute value of negative 6 plus 17, which is also just 6 plus 17, which equals 23. So that is also true, right? So we don't have any extraneous values. Do you have to show the work on that? No, right? One, you're doing it on Delta Math. But if we were doing a test or a quiz, even if it's on Delta Math, you're going to have to send me your notes, right, with all of your work done on it. And in this case, you would have to show me your work on the problem, but you would not have to show me your checking for extraneous solutions. So that's good to know, right? So this is a solution, and this is a solution. So let's try and look at an ugly problem, one with a lot of stuff being done to it. I don't know how crazy they get with the Delta Math ones, but let's look at, I'll do this one because I already did it earlier on the board. Shaylin's in here. She could just look at the board and see the problem I'm already about to do. And this will be the last one because I want to get you guys into Delta Math and make sure that you're all in there. What if I have 9 minus 4 times the absolute value of x plus 10 equals negative 15. Now, I know that I told you earlier that if we have the absolute value of x, it can't be equal to something negative. But right now, we don't have the absolute value of x. We don't have an absolute value set equal to something negative because there's still all this stuff happening to it that we have to undo before we could determine that it's equal to something negative, right? And right now, what we have being done to it is we have 9 being added to it, and we have negative 4 being multiplied to it. So we're going to undo all of that. And we're going to start with the 9 being added to it, and we're going to subtract 9 from both sides. That is going to give me negative 4 times the absolute value of x plus 10 equals negative 24. I almost wrote 25. That would be wrong. The next thing I have being done to it is I have this negative 4 that's being multiplied to it. And so I am going to divide out that negative 4 from both sides. These will cancel, and I'll be left with the absolute value of x plus 10 equals positive 6, right? A negative divided by a negative gives me a positive. So now we're no longer set equal to a negative. So it is a valid problem, right? There is a solution. Hopefully there's two. We've isolated that absolute value, so now we're going to create our two cases. One of them will be x plus 10 equals 6. The other one will be x plus 10 equals negative 6. And we're going to go ahead and solve both of those problems. And all we have to do is subtract 10 at this point, right? All that's being done is 10 is being added to each of them. So I'm just going to subtract 10 from both sides. I'm going to do the same thing over here. Subtract 10 from both sides. And I will get x equals negative 4. And I will get x equals negative 16. Am I going to plug in for extraneous solutions? I'm feeling a little lazy. I kind of don't want to. I'll do 1. So if I have 9 minus 4 times the absolute value of x, and my x is negative 4 plus 10 equals negative 15, what's happening in here? This becomes 6, right? 6 times negative 4 is negative 24. So I'd wind up with 9 minus 24, which does equal negative 15. So that one's on. And then I'd have 9 minus 4 times negative 16 plus 10 equals negative 15. This, again, would be negative 6, but when I took it out of the absolute value, it would be positive 6. 6 times negative 4 is negative 24 plus 9 equals negative 15. So I know these check. Make some sense? Do you want to see any more of them? Or you want to just move on to the delta math? Yeah, we can do another one. Let's do one that has an extraneous solution, since we don't have a sample of that. Oh, let's do one. I got an idea. We're going to do one that has a variable on both sides of the equal sign. So if I have number 4, I think it's number 4. The absolute value of 8 minus 2x minus 5x equals x plus 2. A lot going on there. Only a little bit to move though, right? The only thing we have to move over is this minus 5x, right? And we're just going to do that by adding 5x to both sides. Ooh, I like that color. So I would be left here with 8. The absolute value of 8 minus 2x equal to x plus 5x is just 6x plus 2. Now, when I go to set this problem up and I create my two scenarios, This one is going to be 8 minus 2x equals 6x plus 2. This one is going to be 8 minus 2x equals negative. And I'm going to put this whole thing in parentheses because I have to apply that negative to both parts, right? I can't just apply it to the front and write 6x plus 2 because it's got to apply to the 6x and it's also got to apply to the 2. Does that make some sense? Okay. So when I go to solve this one, it's a little easier, right? But we're going to have to get all of the variables on one side. We're going to have to get all the numbers on the other. But you guys have been doing this for like a week or so now, and you should kind of have that down. So I'm going to start by moving all of my variables over. Minus 6x, right? Which gives me 8 minus 8x equals 2. Then I'm going to go ahead and move the 8 over, right? I'm going to subtract 8 from both sides, and I get minus 8x equals negative 6. It's like we're going to get a fraction for an answer, but that's okay because we're not afraid of fractions. At least I'm not. Some of you guys might be cowards, but I'm not afraid of fractions. I face fractions day in and day out, and they don't intimidate me at all. I'm going to divide by negative 8. I don't know. I'm in a weird mood today. And I'm going to get x equals, I have a negative over negative, so it's going to be positive, right? These are even numbers. Divide them by 2. And I get x equals 3/4. Hides under a blanket. I am just powerful, and I've faced my fears. I used to be afraid of fractions. Now they don't intimidate me at all. Cool like that. We have an extra step on this side because we do have to distribute this negative. So I'm going to be like 8 minus 2x equals, and I'm going to go negative 6, negative 6x minus 2. Now everything's going to work like a regular equation, but I have to first distribute that negative through to each part, right? Because it's not just minus 6x, it's minus 6x and minus 2. That negative has to distribute. So always, when you have a couple of things there, put it in parentheses for the negative side and distribute it through. So now we can do everything just like we did the other side, right? Only this time we're going to add 6x to both sides because we have a negative instead of a positive. We're going to get 8 plus 4x. That is a 4. It didn't look like it. Equals negative 2. And we're going to subtract our 8. And subtract our 8. And we're going to get 4x equals negative 10. And we're going to get another fraction, but it is okay because we're not afraid of them. Except for Valerie. Valerie's afraid of them. Although I think Jacob's a little afraid of them too. Now we're just going to divide out the 4. And we're going to get x equals, this time it's negative because we only have one negative. Divide by 2. 5/2. That is pretty. But are they both solutions? We don't freaking know. I actually do know. I know one of them is not a solution. One of them is extraneous. I picked this problem specifically for that, right? So let's look at it. If I have 8 minus 2x, well, that's 2 times 3/4 in this scenario, equals 6 times, dang, why did I pick this problem? I'm not afraid of fractions, but they do sometimes cause me to have to do a lot of work. 2 times 3/4, well, that's the absolute value of 8 minus 6/4. Ugh. You know what that means? That means I have to find common denominators. Oh, my life is so hard. Equals 18/4 plus 2. I hate this problem already. Oh my gosh. 8 minus 6/4. What is my common denominator going to be? It's going to be 4. So that's like saying 32/4 minus 6/4 absolute value equals blah, blah, blah. 18/4 plus 8/4. I'm pretty good at this. You'd think I had like a degree. I do. I just like to tell you all the time I'm super proud of it. 32 minus 6 is 26/4. The absolute value of 26/4. That's a positive, right? Please tell me this equals 26/4. Oh, good, it does. So this one works, right? 26/4 equals 26/4. Let's try it with -5/2. I wish I'd never suggested we do another problem. It's my own fault. It's my own damn fault. So now we've got the absolute value of 8. Was it minus 2x? Minus 2x? Oh, I got it right here. Minus 2x. So minus 2 times -5/2. I wish I picked an easier problem. I'm such a weenie. I'm like, I'm not afraid, but I am. Did I even put it all the way into the whole equation? I just did this one. I didn't even take it back to the original. It's okay though. It'll still work. Equals 6 times -5/2. What was it? Plus 2? Am I right on all of that? Did I get all that stuff written down right? So here we're going to get the absolute value of 8 plus 10/2. Why does it become plus? Because this is a negative and this is a negative. So when I multiply them, they become a positive. This winds up being minus 30/2 plus 2. And I can look at this right now and say there's no way this is going to work, but we're still going to see it through. We're still going to check it all. This is going to give me 16/2 plus 10/2, right? Equals minus 30/2 plus 4/2. It looks like it actually does work. Am I wrong about that? This is looking pretty darn good to me. This is looking like 26/2 equals, oh no, because this is going to be negative, minus 26/2. And these do not equal each other. So this is extraneous. It was looking like the numbers were good, but we have that -30, and -30 plus 4 is -26. So we've got a negative equal to a positive, and that doesn't work for us. When does a number become positive within an absolute value sign? That is an excellent question. When it is just a number or just a variable, right? So if I have -3, that would equal 3. When I have it, even as just a variable, that doesn't work because, well, it does a little bit, right? It has to be something solo within there. So like all we have in here are numbers. So whatever these add up to be, like if this was -26/2, when we pulled it out of the variable, it would be positive 26/2. And I hate even saying 26/2 because that's 13. And I was driving myself crazy. So like if I had something like x plus 3, we can't just pull that out, right? Because it's not in and of itself. We can't say that's positive. We know it'll be equal to something positive in the long run. But that's when we have to write out our 2 cases. Any other questions? I am going to speed you guys through Delta Math because I want you to get in there. It's www.deltamath.com. And I want you to go there and sign up for the class. My teacher number is 264234. For those of you who've had previous accounts, once you've logged into Delta Math, you're going to have to go to Tools and select the class, put in my teacher number so it can bring up the class. Make sure that you pick Algebra 2 and not pre-calculus, or your homework is going to get harder.